Hello, Pathway people. Mr. Klein here. I'm going to talk to you a little bit about something called the 5-number summary. It's a way of describing the distribution of data. So I got some data here. These data represent the heights of people in this class. The 5-number summary is finding these 5 values, the 0th, 25th, 50th, 75th, and 100th percentiles. Now, the way that we go about doing that is a little bit different than what we learned last class. So let's get into it. First thing you do is you put all of the data in order. I am such a nice guy. I did that for you already. By the way, write this down as I'm going through it. The second thing that you want to do is you want to find the sample size. So let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Sample size is 21 individuals. Now, we want to find these percentiles. The 0th, the 25th, the 50th, the 70th. Oh, that's a lovely percentile. And let's not leave out the 100th. And the one that we're going to find first is the 50th percentile. Now, you already know that the 50th percentile is right in the middle. And you know a name for that. It is called the median. So since there are 21 values, I know that I can break this up into 10, 10, and 1 in the middle. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This would be the 11th value right here. So our median is going to be a student that is 67 inches tall. Now, when I did that, it broke the data set into 2 groups. 1, 2. The first group has 10 values in it, and the 25th percentile would be the middle of that group. Now we have a name for that. We call it a quartile. Specifically, this would be quartile 1. So the value of quartile 1 would be, if I go right here, see how that divides these 10 values into 2 groups of 5. And so right in between them, quartile 1, which I'm going to call Q1, would be the average of the 62 and the 63, which is going to give us 62.5. So quartile 1 is someone who is 62.5 inches tall. That's like 5 foot 2.5. All right. The 75th percentile is quartile 3. It's easy to remember, right? 75 cents is 3 quarters. 25 cents is 1 quarter. Quartile 1, quartile 3. All right. So the third quartile, you play the exact same game, but you do it over here. So if I divide right there, I get 5 and 5. And so our third quartile would be equal to the average of the 71 and the 73, which gives us 72. So a student at the 75th percentile, also known as quartile 3, is 72 inches tall. That's 6 feet. The last 2 are simple. The 0th is the minimum. Okay. Now, I know we talked last time about how there is no 0th percentile. But for our purposes here, this is the best answer we can give. So the minimum is 60 inches tall. That's 5 feet. And the 100th will be the maximum, which would be 78 inches tall, also known as 6'6". So there's your 5-number summary: 60, 62.5, 67, 72, 78. Now, what's the relevance of those numbers? Basically, it breaks down to this. We know that between 60 inches and 62.5 inches, 25% of our data values will sit there, roughly. And then we call this the next quartile. Between 62.5 and 67 would also be 25% of the data. Between 67 and 72, there's another 25% of our students. And then finally, between 72 and 78, there's the last 25%. So essentially, the 5-number summary takes our data and breaks it up into 4 groups, each containing 25% of the data. And that's the 5-number summary. Here today, we're going to talk about box plots. You've learned about something called a 5-number summary. 5-number summary is really useful because those 5 numbers, 1, 2, 3, 4, 5, will break our data into the bottom 25%, the next 25%, the next 25%, and then the top 25%. And so it would make sense for us to have some sort of graphical representation where we could see those 4 25% broken up for a data set. And that's what the box plot does. Now, today's data is going to involve something called the grip strength. And grip strength I learned about because I'm in physical therapy right now for this here shoulder. And what grip strength is you hold one of these little tools like the one that you see right here, and you squeeze as hard as you can, and it measures your strength in the pounds of pressure that you can create. So for men, let's suppose that we've got a large data set. I'm not going to give you all the data today. I'm only going to give you the minimum, quartile 1, median, quartile 3, and the maximum. And so for these men, I want to draw the box plot. And here's how we go about doing that. First, you need to make yourself a little number line. And on that number line, make sure that you include a label. So these are going to be grip strengths. And it's measured in kilograms of pressure. And then let's suppose we start with the males. And all I'm going to do is take this number, this number, this number, this number, and this number. Those 5 numbers from the 5-number summary, and I'm going to plot them on a line. It does not matter which line we pick because there's no vertical axis for a box plot. So let's see, I'm going to choose this one right here. And there's 76. So that's the min. Move along. 100 would be our quartile 1. 103, really close to that. About right here. It's going to be our median. Quartile 3 would be up here at 120. And then our maximum is at 160. Oh, that's a little off the graph. I'm going to need to extend it a bit. All right, so I've got those 5 points plotted. We take quartile 1 and quartile 3 and we draw a box around it. So that box would look something like this. Vertical line, connect, connect. And that box that I just drew, that represents the size. Oh, I don't want that. What was that? That represents the interquartile range, which in the case of this data set would be from 100 to 20. So that would be an interquartile range or a spread of 20 pounds. Okay. The other thing we do is we mark where the median exists. And the reason we want to mark where the median exists is, besides showing us where the middle is, it tells us something about the shape of the distribution. Because 25% of the data is going to be in this little box right here. And then 25% of the data is spread out in this box right here. So the fact that the median is way to the left actually tells us that this is going to be skewed to the right. And you can kind of picture that if we made a histogram, it would be really tall right here, and this right here would be sort of like the tail. So if your median is way to the left inside the box, that tells you that it's skewed right. All right, so here's 25%, here's 25%. The other 25% are from the min to Q1 and from Q3 to the maximum, which I never labeled. And we draw some whiskers in to represent those to 25%. Okay, so there is our box plot. We can look at this box plot, we can tell the shape, and we can tell where the 1, 2, 3, 4 quartiles are. Now, one thing that I notice is that this last quartile is much, much larger than all of the other quartiles. And I'm kind of wondering if this point right here is an outlier. So let's run the outlier test to see if that's actually the case. Recall that the upper outlier test goes something like this. You need to take Q3 and add to it 1.5 times the IQR. So in the case of our data, the third quartile is right here. It's 120. So it would be 120 plus 1.5 times the interquartile range, which we calculated is 20. Now 1.5 times 20 is 30. So 120 plus 30 would give us 150, meaning that any value that's larger than 150 is going to be an outlier. Translation, this is an outlier. Now, with box plots, we modify them if there is an outlier. Okay? In fact, what I'm about to do is called a modified box plot. So the first thing that we do is I'm going to erase this guy. And I'm going to mark back where that outlier was at 160. And then to draw the rest of the graph, we need another piece of information. So suppose that the next largest value is 147. Now, 147, according to our outlier test, is not an outlier. So what we do is we mark where 147 happens. So it would be right about, let's see, right about there. And then we connect the whisker here, leaving a gap. And that gap helps us to see, listen, there's nothing going on right here. This is our only outlier. Now, suppose that I actually lied and there was another value in here between the 147 and the 160. Let's suppose there was a 157. Well, 157 would be an outlier, and we would mark it right here, and then we would have 2 dots. So anytime you see dots on a box plot, that is a modified box plot, and it has outliers. Now, I'm going to be quiet for a minute. What I would like you to do is, in the space below males, I would like you to draw a box plot for the female data using the 41, the 60, the 70, the 100, and the 110. So pause the video right now, and after you're done, you can check your work. Okay, folks, take a look. This is what your female box plot should look like. If that doesn't make sense, when you see me today, we can talk about it. Once we've got 2 box plots like this, the idea is it should be pretty easy for us to do a comparison. So if we were going to compare these, as always, we would talk about the shape, the center, and the spread. For the shapes, we would say that both of them are skewed right, because see how for the female data, this median is a little bit to the left side of the box as well. So both skewed right. For the center, anytime you're looking at box plot data, since you don't have the mean, you have to use the median. So I would come up here, and I would look at these 2 values, and I would say that the median male grip strength is 33 kilograms greater. Now for the spread, when you're looking at the box plot, recall there are three kinds of spread. There's the standard deviation, the IQR, and the range. However, you can only see two of those when you're looking at a box plot. The one that you can't see is the standard deviation, so we don't talk about that. The range is not informative because there are outliers, so we're going to use our interquartile ranges here. The IQR for the male data, as we already talked about, was 120 minus 100 is 20, and the IQR for the female data is 40. It's considerably larger, and that's easy to see because if you look here, those interquartile ranges are the widths of the boxes, and the box is much larger here. So we would say there is more variation in female strength because IQR is 20 kilograms greater. And there it is, folks. You know how to make a box plot, and you know how to compare two box plots.